What's up guys, welcome back to another video. This video here is longer than what you normally see from me. Now the reason it's longer is because we got into Navien's head office in Canada, Vaughn Ontario, and we're working with national trainer Mike Wills on breaking down maintenance, install, and service tips on a Navien Combi fire tube boiler. You guys can use this as a resource for your service calls, before your installs, anything you want to use it for. Keep it in the back of your mind. It's there. You can reference whenever you feel like it. Just so you know, guys, when you watch the video, it is filmed in portrait mode just because most of the content is going to social media, and social media likes the portrait mode over landscape. So when you watch it, it's going to be in portrait mode. Please like, comment, subscribe to the channel, guys. We're trying to grow a little bit and bring you more HVAC and refrigeration education. So I'm at the Navien head office, and what we're going to do is go through this Combi unit here with Mike Wills, national trainer, and we're going to give you guys some install, maintenance, and service tips. Mike, go ahead and break this down for us.
This is one of our Combi boilers. We have both the Combi and the non-Combi. Major difference is on the Combis is we have the capability of doing domestic hot water, much like a tankless, without having an exterior storage tank or indirect fire hot water heater. It is a little bit longer than our non-Combi boilers, primarily because you do have at the bottom of it, you have your circulator pump and all the valves in that to switch over to domestic hot water. All the settings are done through the main control panel, and that will be both for space heating and the domestic side.
I see a ton of components in here, so I think before we do anything, we should probably go through and label the major components in this cabinet. So when we're talking about them later, everybody knows exactly what we're speaking about, right?
Major component, we have our fire tube heat exchanger, main component of the boiler that exchanges the heat from the burner to the water.
Okay, so Mike was explaining the fire tube boiler over at the actual boiler. This is a cool cutaway. And if I spin it around, essentially, if we're going to break this down to basics, this is a fire tube heat exchanger. We're going to send basically the combustion or the flames down through these tubes, and the water is going to surround it, because you can see my finger right here. The water will surround it, and we're going to send the heat and the combustion gas or fumes through these plates here.
Nope, that's correct. So pretty much the burner sits on the top, flames go down these tubes. You'll notice inside these tubes they have turbulators. That makes sure that you get the best heat transfer to the water. This jacket here has the water inside of it, heats it up, and then it flows out. By doing this, you don't have nearly the resistance that you do through a water tube heat exchanger, provided for smaller circulators. Also, if there's a lot of sediment or buildup of in the system from past history, this will be a lot more forgiving and allow the system to flow better. Doesn't excuse flushing a system before you do a change out, but it does make life a little bit simpler. Blower motor up here and blower air fan, which is operating the combustion air. Also the fuel air mixture, which is then pumping into the burner, which is on top. These are mesh burners, which you can do some maintenance on, which we will talk about. Down to our gas valve, major components here. You're gonna have your gas riser. If you're ever doing a conversion to propane, this is what's gonna come off to allow you to put your new orifice in. Dropping down through the boiler, on the front here, we've got our main control panel. All of our boilers have the exact same control panel, our resi boilers that is. Commercial boilers have a touch screen. Behind that, the PCB. Left-hand side is all of our high voltage inputs and outputs. On the right-hand side, we have all of our low voltage, which is thermostats, sensors, that sort of thing. Behind this, and as you can see here, it's called our waterway assembly. That is our plate heat exchanger, along with a circulator, which is also our boiler circulator, three-way valve, and various other components that operate the domestic and allow this to do domestic as a combination unit. The major difference between this and our non-Combi boilers is this assembly back here does not exist.
So you covered some major components in here, Mike, and I'm just going to point to a couple of things and just quickly describe what they are. So again, when we're talking about service and maintenance, people are understanding exactly what these parts are. So this one right here.
That's the igniter transformer. So that will take your 120 volt signal and up it for the igniter. It's fairly easy to work on and check if there ever is an ignition failure. So, and you can see the igniter cables coming off up here and going into the combustion chamber.
Okay, then we got a flame rod here, so we are doing flame rectification, is that right?
Yep.
Perfect. Okay, so this device here, it's a brass body and it looks like it's got some sort of limit switch on it, and then it's also got this other harness down here. What exactly is this part we're looking at?
It'll tell us the temperatures that are coming out of the heat exchanger. So if we're ever getting an issue with the water that's not hot enough, we can check via the main panel, and then we can now go up to these, ohm them out, make sure that they're actually doing what they're supposed to be doing.
And this is our control board. I mean, it is what it is. Everybody that looks at it knows that this is doing some form of control, and then we have this onboard interface, right? That's kind of self-explanatory, but when you come up to these things for the first time and you're seeing stuff like this, these three things here, maybe talk about each one of these for about 10 seconds so we know exactly what they are. So let's start with this one that's labeled Navien right on it.
Okay, so that's our three-way control valve for domestic hot water versus heating. Pretty much with that, what it does is it redirects the water flow into the domestic hot water heat exchanger when there is a call for heat or for domestic, and pushes it away from the heating side, providing for domestic hot water.
So this one's labeled mixing, so some sort of mixing valve attached to an actuator of some sort?
So it will help mix the water temperatures on the domestic hot water side to the temperature that you put in for the set point, and try to maintain, or will strive to maintain that set point on the domestic hot water. So if you put in 115 as your set point, it will mix in any cold water that's required to maintain that 115 degree set point.
This one labeled flow right beside it. What does this one do?
So the flow control valve is in all of our units. It's in both of our tankless units and our combi units, and its job is to adjust the flow to maintain that set point temperature on the domestic hot water side. If the set point's not being met, it will start reducing the flow to allow that set point to catch up, and vice versa. It will open up more depending on what that set point, where that set point reading is. So its job is purely to maintain the set point temperature.
Shake that up, Mike. So this is a NaviClean, right?
Yeah, this is what will be internal to the NaviClean. We've got the NaviClean on the return side of the system here. So what happens is the water's flowing back into the boiler. Any of the particles, like in this, will be pulled out, and they will be gripped onto by a magnetic rod that goes down the center of the unit. That rod that will have to be cleaned on a regular basis. Not only does this protect the boiler itself, but any of the new ECM style of pumps, the new high efficiency pumps, all have magnets in them. They don't like the magnetite either in the system, so this will ensure that they have a long life as well.
Now you recommend to put one of these on every single install because you never know what's in the system, and it's just basically like putting an air filter in front of a furnace. So when it comes to install considerations, we've talked about the water side and keeping the water clean. Now what about the venting side? Is it recommended that you pull the air from the outside rather than inside the internal space?
We do recommend direct venting, as generally the air is cleaner. You don't run into some of the problems that you do with internal air from a building and or air quality issues. If you are pulling from the room, please ensure that the air is properly treated and you're not pulling any chemicals or any other issues into the unit.
When it comes to venting, there are some choices, right, that we're going to use.
Yep.
We're using System 636 here.
PVC, yep.
PVC. Now, when would you step it up and use a CPVC?
If I'm running very high water temperatures, so if I was running some things like some air handlers out there, older radiators, like copper fin tube, you may end up having to put PVC or CPVC or polypropylene venting. So if you're disabling the temperature sensor for the stack temperature, you want to make sure that you are using either CPVC or polypropylene, as they can withstand the higher temperatures.
So this manifold down here, this is a part of a kit you can get from Navien. Maybe just tell us what it is and some installation tips around this.
So this kit here is one of our stainless steel manifold kits. This kit just allows to ensure that the piping is properly spaced. You have your two closely spaced T's. You're going to get proper flow through the boiler as well as through the system.
So we're going to do some troubleshooting and we're going to do a little bit of service here. So this is the ignition transformer. Now, if you get a code 003, it means that we have a failure to ignite. Is that right, Mike?
That's correct, yeah.
Okay, so what we're going to do is we're going to hook up the manometer. We're going to check our manifold pressure. If it's good, then we're going to check the voltage to our ignition transformer and go through a couple of scenarios why you might not be lighting off. So to check this, what we're going to do is we're going to check the offset pressure tap here. And if you look in the manual, it tells us what we should be reading. Here's our chart right here. So when we check the offset port, we should be negative 0.02 plus or minus 0.01 in low fire. So we're going to check that right now, and here's your offset port here. Now you can see there's a screw in here. All we have to do is crack that screw. It doesn't have to come all the way out to test the gas pressure. The other thing we're going to take note of here is that they want you to connect it to the positive side of the manometer. So we have a positive side and a negative side. We're going to connect our tubing to the positive side of the manometer. Here's our manometer reading right where it should be according to the manual. If it's not where it should be, what we have to do with the gas valve is take the cap off here and take this 5/32 Allen wrench and then turn it either left or right to get the reading that you require for the proper flow. So the next step after gas flow is making sure that we have the correct voltage at our ignition transformer. That's what we're going to do next. Also make sure your connections are on properly, and we also have a proper ground in place as well. So I've set my meter to max volts just so we could capture what the maximum voltage was coming into the ignition transformer. It was 121.7. That is the correct voltage to power this up. Now, if you don't have the correct voltage coming in, you're going to have to trace the wiring back. Maybe you got a loose connection on a Molex plug. Maybe there's something wrong with the main control board. If you do have power coming in, but you're still not getting a spark, then most likely your ignition transformer has failed and you're going to have to replace it. So if your gas pressure is not correct, just remember it could be a few things. It could just be as simple as a setting. You could have a dirty blower wheel. You could have some issues with your venting being partially blocked. So check your gas pressure first and then start checking everything else if it's not correct, starting with your setting. If that doesn't work, start looking for things that could obstruct air or gas flow. Something that's super important on a maintenance is to pull your electrodes. We have a flame rod and we have an igniter. So we're going to pull both of these for inspection, and if they need to be cleaned, guys, we're going to clean them up. So these are just going to pop off. Very easy to take these off. We're going to use a Phillips, a stubby Phillips, and we're going to pull these screws right out. So this is our flame rod that we have pulled out of that piece right there. And if this gets coated with debris, it can cause ignition failure. So we got to pull these out on a regular service and maintenance and make sure that they are clean. So here's the igniter, and you also have to keep this clean as well. The rod that's covered with the ceramic portion is where we're going to send the voltage down to create our spark. The other rod that's connected to the plate and connected to ground will be our grounding rod. Anytime we're working on a closed loop hydronic system, one of the things that we need to do is we need to be testing the water on a, would you say on an annual basis, Mike?
Yes.
Yeah. So here is a test kit right here. And if we go to the back, we can see that if we land in the 6.8 to 7.8 pH level, we are good there. So this is really important. So if our water is too acidic or too alkaline, we could have some issues inside a closed loop boiler. So the next thing we're going to do here is we're going to pull this burner assembly out, because once in a while you got to pull it out for inspection. So we're going to loosen these 4 screws and remove them. There's a sliding clip here. We're going to pull that out, and any wiring harnesses and also the tubing also has to be pulled as well. So 4 screws, clip, harnesses, and tubing, and our fan assembly should pull right out. We're going to pull the burner apart, but I just wanted to show you this. This is a 16-inch number 2 Phillips that is basically a custom tool for Navien. Now you can basically take this whole water heater apart by using the screwdriver. So if you guys are working on Navien or plan to, get yourself one of these screwdrivers. Now the other thing you may want to look into is one of these sticks right to the side of the boiler, and all your screws can go there so you don't lose them. So we've got the assembly out, and first thing I'm going to do is look at the state of the blower wheel. Is it dirty? Is it clean? Now we're going to remove the burner now that we have the blower assembly out of the way. There's 4 screws. There's one here and one there and all the way around. So also too, we want to remove any sort of harnesses that we have, and then once we loosen all 4, we can turn this and then we can remove it. In order to unbolt the burner assembly, we have to use a 10 mil socket. Or if you can get a Phillips in there, you can do that, but I'd recommend the socket. We've got the burner out, and this mesh here, now if that becomes dirty, you can use a vacuum or some low pressure compressed air or low pressure nitrogen to clean it. You don't want to use anything high pressure or a wire brush because you don't want to damage it. So if it starts to get dirty and starts to clog up a little bit, vacuum and some low pressure compressed air. So there's a little damper in there that Mike just pointed out to me. We want to flip that open, and this is where we're going to put our vacuum in, and we're going to suck any debris off the top of that mesh. Just some food for thought, or perhaps a good idea. If you're going to take the burner apart or anything apart, it might be good to have a gasket kit on hand. So if you take it apart and the gasket is worn or it gets damaged by removing it, you have some spare gaskets to put everything back together. So as I've got this blower assembly sitting on the floor, I noticed this interesting part right here. So Mike has brought it over to me in my hand. This is the dual venturi. If we flip it, we can see one side is open and one side has a bit of a flapper there. So this here is responsible for opening to give you a little bit more capacity. And if you get an 060 alarm, which is right here, abnormal operation, dual venturi, there could be a bit of an issue here. Now Mike is going to walk us through how to test this from the control board. Mike is going to take us through test mode on how to test the venturi and other items within the boiler as well. Take us through it, Mike.
All right, so if we want to figure out if there's a problem with any of the components, some of the major components, what we're going to do is hold the menu key and the back button together for 3 seconds. What that'll do is it'll bring up the service and installer menu. I'm going to scroll down to test mode. So once I get to test mode, I push on the dial. It gives me a list here of a number of different items in the on the unit that I can test. Some may not be hooked up, some may be. So in this case, I can go down to the dual venturi and check to see if it is working. So I go all the way down to the venturi. I want to turn it on, and once we should hear an audible click when it goes on. Same when I go off. That tells me that the venturi is working. If when I go into this and I hit one of those on or off, it goes red, the screen starts flashing red, it generally will come up with an error code in the case of the dual venturi at 060. That will tell me right off the bat that the dual venturi has a problem and we would probably need to replace it. We can check the voltages on it, but if it is coming up that way on the screen, and this applies for anything, I can do fan motor, circulators, that if it is coming up with a red flash, there's either a problem with the component or the wiring directly to.
So this is our intake on top for our combustion air. Underneath, you can see that we've got a bit of a mesh screen. Now, if we look at the error codes, if we come to E1110 abnormal air pressure, it says ensure that the exhaust pipe is free of obstructions, clean the intake air filter. The way we're going to do that is we're going to undo the screw. Once the screw is out of the way, we're going to pull the whole assembly out, and we take that to a sink and give it a wash. So this should be checked periodically on maintenance and service. So just a bit of a tip that I'm going to bring you guys is if you're going to be wiring any external circulators for zoning and you're going to wire it to the unit itself right here, you can actually have the fuse blow if the pump draws over 2.5 amps. So that's really important. So if you're going to ever attach an external pump circulator to this panel, make sure it draws less than 2.5 amps or you could blow your fuses. So we've done a bunch of install, maintenance, and service tips on this Combi. So what we're going to do now is take a combustion analysis on this water heater over here. So something really important is you don't want to go putting your analyzer probe into a flue where the unit hasn't reached steady state yet. Let it fire up, let it reach steady state. We're going to put this one in low fire and we're going to check our readings. So we've reached low fire and we're going to install our probe. All right, so right now we're on low fire. The manual is asking for this specific model to be at 8.9 CO2. We are currently at 8.57% CO2. So we're pretty close to that point. Now, if your readings are not correct or way off, obviously you want to check the cleanliness of everything. Once you know that everything is clean, and it could be your air to gas ratio, you can come down to your gas valve. You can make slight and minor adjustments right here on the gas valve. Obviously, you want to be watching what's happening on your analyzer when you're doing so. If you guys stay till the end, you guys are champs, because now you've just absorbed a lot more info than you previously had, or you had a refresher. So use this as a reference tool, guys, when you're up against a Navien install or service or maintenance, guys, you can always come back to this video and reference some of the things we talked about. For now, guys, please like, comment, subscribe to the channel as we grow. Happy HVACing.